For this training, we are going to talk about the introduction to generative AI images. So first, there's two different types of AI. The first one is traditional AI. And traditional AI refers to systems that are designed to perform specific tasks based on what the data sets they have been trained on. So two examples of this would be the chatbots, which talks about the programs designed to simulate conversation. So if you're ever on a website and you have to ask a couple of questions, it pops up a chatbot and it can really only tell you the information that has been trained on. It cannot create any new information. Very similarly, virtual assistants. So we're talking about Siri, Google, Google, and a lot of those virtual assistants that they can actually assist you with various tasks, but they can't necessarily make information up for you. So this is the traditional AI component. Generative AI and large language models are the AI systems capable of generating content based on inputs and prompts, often utilizing deep learning techniques. So a few examples of these would be ChatGPT-4, Dolly, Gemini, which is Google. Google also has a vlogger tool, Copilot, as well as Claude. Every single day, it seems like there's a new generative AI tool coming out into the universe of applications available to us. So there's definitely been more and more generative AI tools created out there. So for generative models, there's three different types of generative models. There's the generative adversarial networks, GANs. There's variational encoders, VAEs, and then there's recurrent neural networks, RNNs. For GANs, you have what they are they're machine learning models that use two different types of neural networks to create new data, and then instances that resemble training data. So it takes of training from here, and it creates the information. The variational encoders are models explicitly designed to capture the underlying probability distribution of a given data set, and then it generates novel samples from there. And then for RNNs, we have the sequential data to solve common problems, see language translation as well as speech recognition. So for the examples of these, so for GANs, we have medical imaging and video game design. Variational encoders, we have fraudulent transactions, medical imaging, as well as text and music generation. And for RNNs, we have speech recognition, language variation, and video activity recognition. So there's a wide range of AI image generators out there, and it seems like every single day there's new tools out there, particularly with the generative AI. So this just shows you a couple of the more popular ones. So we do have the Adobe Firefly, as well as Dolly 3, which is associated with ChatGPT. And then there is Jedi by Getty Images. So Getty Images does have a lot of open educational resources, and now they're getting into the generative AI as well. So how does AI imaging actually work? So they are trained on millions or billions of image text pairs that are used. So here's a picture of a dog. This is what a dog is. So the tool learns what dogs are, the color red, etc. are. So here's a picture of a dog. This is a dog. Here's the color red. This is red. Here's the color blue. This is blue. Once it's trained, the AI tool can interpret almost any prompt. And the next step is to render the AI generated image using a process called diffusion. So what's diffusion? So what it does is the diffusion model works by destroying the training data through a successive addition of this Gaussian noise, and it learns to recover the data by reversing the noisy process. So it goes from a lot of the static noise and it goes into this image. So after the training, we could use this model to generate data by simply passing randomly sampled noise through while learning the noisy process. So it creates this noise, but all of the pictures and all the images have its own noise. And when you put them together, that's how you get the image. One of the biggest concerns right now with AI, other than students using it in nefarious ways, is deepfakes. Now, deepfakes are falsified media where a person in an existing image or video is replaced with someone else's likeness using artificial neural networks. So this is definitely deep learning algorithms that analyze existing media to learn patterns and recreate facial expressions, movements, and speech. So this is actually a really cool technology. And it can be used for simple purposes. One of the best examples I have is there's a David Beckham commercial where he's in the commercial, he starts off speaking in English, and they actually use AI so he can speak 9 separate languages. And that's a good use of this tool that, it's for marketing purposes. I imagine that David Beckham might know a few languages, but he might not know all 9. So it's those type of benign purposes like entertainment that could be beneficial, but it also posed significant risks in spreading misinformation and damaging reputations. There's also been cases where a deep fake video of a board of trustees saying that the company was losing so much money and they were in they're in really big trouble, and I believe that their stock prices crashed like by $15 million overnight once this deep fake got posted. So it can have a significant risk with people as well as celebrities and businesses, deep fakes. And one of the things that we also have to think about is the deep fakes with the videos altering politicians' speeches or celebrities' appearances. So, another key important part of deepfakes is that deepfakes videos could alter politicians' speeches or celebrity appearances. And this definitely raises concerns about the authenticity of visual content. And what's really interesting is, as you can see on the right hand side of the video, this is not Morgan Freeman. So, it's a deepfake singularity. So, this is a video that was created as an example of how people could deepfake celebrities into images as well as videos. What you can see is this looks like Morgan Freeman. However, this is the individual that they're actually in the video of, and they're just overlaid Morgan Freeman's face over his so that it looks like Morgan Freeman is saying that what he is saying. Here's some more examples of deepfake photos. So these are AI generated photos. A lot of them are actually getting better and better as we can see it. You can see that these are like the Hawaii fires. So these are to generate emotions, either anger as well as sadness. And then there's always my favorite of the Pope in a puffer jacket, because obviously you would assume that this is a fake photo. So ways to spot a deep fake. So irregular lighting, odd reflections, small details out of place, objects' edges flickering, as well as inconsistent coloring or shading, or out of phase lip syncing. So one of the things that I did is I actually created this image on the right hand side, and I said if the Brooklyn Nets and the New York Knicks merged, combined forces, combined teams, like send me an image. So as you can see that this image looks really good. So it has a New York Knicks players looking really scary. You have the Empire State Buildings, you have the Brooklyn Bridge. So it looks like a really great photo. But then if you actually look deeper into it, look into the middle of the photo where you could actually see the players. Whose arms are all of these players? And this is where you could actually really start kind of deeper diving into photos. Is one of the things that AI is getting better at, but not really great at, is extra arms, missing limbs, missing fingers. So you could kind of see that, like, whose arms are these? Like, is this guy's? Is this guy's? So it seems like this it got a little muddy over here, because when I said to merge them or combine them, it literally did that, and it's making some crazy arms looking over here. So we do have at New York Tech, we do have a data classification matrix, which is a really great tool to discuss what is public data, restricted data, as well as confidential data. So public data is press releases, course information, and research publications. So this is data that you could probably find elsewhere on the interwebs as well as Google and on our website. Then there's confidential data. So confidential data is data protected by the state or federal privacy regulations. So you can think about this as HIPAA and FERPA, as well as data protected by confidential agreements. So this is social security numbers, maybe home addresses, additional data information. And you never want to put this information into an AI tool because that allows a security risk and then allows other people's information to be sent elsewhere and used on the dark web. Restricted data is all institutional data that is not explicitly classified as confidential or public, but should be treated as restricted data. So this is the gray area of our data, right? So we want to take a step back and think about the purpose of utilizing this AI tool with this data. Um, so this data we'll go through this a little bit further, but this data you may have to actually scrub of any identifier information as well as make it more anonymous in order for it to be used in a AI tool. Or you may want to not even include this type of data in an AI tool even after removing all of the identifiers that you can. So a couple more ways that you can secure your digital footprint is you can use anonymization techniques. So before submitting the text for grammar checking, you want to anonymize or alter names, locations, and identifiable details within the document. So you want to make sure that it does not know a lot of information about you, but it knows enough to be able to provide you a response. You want to use hypothetical scenarios or anonymize the content to avoid a context to avoid revealing specific strategies or technologies. You do not need to have a very specific example. You can actually use hypothetical scenarios as well. You want to understand and leverage the privacy policies. So this is where you want to review and understand the updates in the privacy policies of large language model providers. Ask the service provider about the data retention and deletion practices to assess the security of your data. So you saw that I did that with a sample privacy statement, but you want to make sure that you understand fully where your data is going. You can also seek secure alternatives. So for sensitive discussions, opt for platforms that offer end-to-end encryption to ensure that conversations remain confidential. There also are opportunities for you to examine the free version versus the paid version um, of a tool because sometimes the paid version can provide more of a secure uh, encryption and secure alternate to the free version. So that's something that you may want to also examine is, okay, how do they secure my data? How am I secure with the free version of this tool versus the paid version of the tool? And if you're going to be using the tool a lot, you might as well go with the paid version to keep you safe.